But let us do a quick recap first for what we have learned yesterday. If you are given a fraction that looks like this, 3x squared plus 11x minus 51 divided by x minus 10 x plus 8 squared. How will you convert this to partial fractions? The very first step, what is it? A? No, not A yet. You must, there's something else going through your mind. That should be going through your mind. It is the first thing that I touched on for this topic. Proper fractions and improper fractions. So you need to check. Okay, is this a proper fraction? Is this a proper fraction? Why not?
Because when you expand the denominator, right, the degree is 3.
Okay. So what about it? Okay, so this is proper. This is a proper fraction, so I can go ahead and separate them. Right? If it is an improper fraction, we need to do long division first. Okay? Now, what happens in the denominator? What should I put in the denominator? What do you want me to put first? X minus 10? Okay. Then what goes in the numerator? What should I put? A. Okay, it is a constant for us to determine. Now, what about the second fraction? X plus 8. What should I put in the numerator? B. Is that all? Is that all? No. Okay, what else should we have? X plus 8 again? Because this x plus 8 square is actually made of x plus 8, x plus 8. Therefore, I should have an x plus 8 here and an x plus 8 here. Is that correct? No? Not correct? Are you sure not correct? But it looks like it should be this way. X plus 8 squared is made of x plus 8 times x plus 8. Why shouldn't it be x plus 8 over here and x plus 8 over here? Do you know why? Okay, for those who watch the video, I'm sure you can tell me, hey, this is wrong. We need to have a square over here. That's the first step to learning. But do you know why? Anybody knows why? What about linear? Okay, so this is it. It's one thing to just memorize and just take what your teacher says and then you just plonk it in. It's another thing to understand why. And I want everybody here to understand why. Now, suppose we were to combine these three fractions. What do you think will be the denominator?
X minus 10.
Okay.
X plus 8.
Exactly. Do you get an x plus 8 square? You don't. That's why I need to have a square over here. And that is the reason, okay? B could very well be a value of 0. This term could disappear. I do not know. That's why we need to find out. Okay? So now we are left with one blank over here. What goes up there? C. Okay. So once we have this, what is the next step? To solving for A, B, and C. You see, the question asks you to put this in partial fractions, means your final answer is going to look something like this. But you cannot leave it as A, B, and C with unknowns for me to find out. You are supposed to find out the unknowns. The very first step is to be able to separate them into the partial fractions. They are all part of a fraction. Then find out the values of A, B, and C. So now, how do we find out A, B, and C? Let's see how effective the video was. What shall we do? Cross, multiply, remove the denominator. You guys seem to be saying the same things. Expand what?
Expand the denominator.
You mean expand this entire thing out?
No.
Then what do you mean? Multiply throughout by what? By the numerator or denominator?
Expand the denominator throughout the numerator.
Okay, I think all of you mean that we should multiply everything by this highlighted portion. Everything. On the left, on the right, we multiply by the highlighted portion so that on the left hand side, what am I left with? 3x squared plus 11x minus 51. Right? And on the right hand side, I'm going to skip steps, and this is what I expect you to be able to do as well. I'm going to multiply this by the green color highlighted part. What am I left with? A bracket x plus 8 square plus next B then x plus 8. Okay, any more? C, x minus 10. Excellent. With this, you can also solve for A, B, and C, isn't it? What's the best way to solve for example, I want to find the value of C. What's the best way to do it? Sub x equals to negative 8, right? Okay, so I don't want to write sub x equals to negative 8, blah, 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 blah. So I shall do this. Let fx be equals to 3x squared plus 11x minus 51. So my next step, f of negative 8 equals to 3 negative 8 squared plus 11 negative 8 minus 51. And this is supposed to be equals to, let's look, if x becomes negative 8, this disappears. This disappears. And I'm left with C multiplied by negative 8 minus 10. Solve for C. Right? Okay, we do the something similar for the value of A. Then for the value of B, what value of x would you like to use? What's the convenient value for B for x to be in order to find the value of B? We have already used negative 8. We have already used 10. So this one is to solve for, to find C. This is to find A. Okay, so what would you like to sub in? 0, I agree with you. So that all this disappears, right? Then we are left with negative 51 equals to the value of A, which we have already found out. 8 squared plus B. 0 minus 10, negative 10. And then 8 plus C, which we have already found out. And negative 10. So you can easily solve for B. Once you have your A, B, C, put them back here. And you're done. Get full marks. Is it difficult? No? Yes? What if it's an improper fraction? Then we need to do long division first. Long division will allow us to get, let me see at the top. Wait, no, not here. So this is on, I believe, the first page. Here we have a improper fraction. So we do long division. You look at the power in the degree of the numerator is 3. Degree of the numerator is 1. Since the degree of denominator is not bigger than degree of numerator, therefore it is an improper fraction. I cannot express it as a partial fraction. So I need to do long division to get this. My long division gives me a polynomial plus a proper fraction. In this case, the proper fraction over here cannot be split up anymore. But it could be a case where your proper fraction at the end, or rather your remainder, could be something like this. 2x plus 1 over x plus 3, x minus 4. Okay, something like that. Then you apply partial fractions on this. That is case number 4. Okay, you're already considering many cases. In our textbook, there are 4 cases. We covered 2. He thought of the last one already. Okay, so let me go into the third case first. That will be on page 36, where it says a quadratic factor in the denominator that cannot be factorized. What are quadratic factors that cannot be factorized? Quadratic expressions look like this: ax squared plus bx plus c. Okay, you should be very familiar with this. Sometimes it can be factorized into something like this, right? Sometimes it cannot. When is a sure case of when it cannot be factorized? Okay, let me give you an example. X squared plus 3. Can you factorize this? You can try, but you won't be able to. Okay, then I'll show you more examples. Then you tell me what the pattern is. X squared plus 9. Can or cannot? Can. Okay, what does this give us? X? X plus 3, x minus 3. Agree? So is this factorized? Is it factorized correctly? So can this be factorized? Okay, let's just do a test. Okay, some of you seem to be unsure. On this side, okay. So I've got a left hand side and a right hand side. Okay, let's look at the right hand side. I can expand it. X squared plus 3x minus 3x minus 9 equals to x squared minus 9. Is it equals to left hand side? So it's not equals to left hand side. So this is wrong. Okay? So back to the question, can this be factorized? Cannot be factorized. Let's have more examples. X squared plus 12. Can it be factorized? No, all these are examples of quadratic expressions that cannot be factorized. So I shall show you now the general form. As long as you see a quadratic factor in the denominator that looks like this, x squared plus c squared, then it cannot be factorized. Okay? Do all these that are circled have this form, x squared plus c squared? Do they? No. Okay, which one confirm has the same format? X squared plus 9 confirm is x squared plus c squared, right? What is the value of c? 3. Then are you saying that the other two is not in the same format? Did I say that c must be an integer? I didn't, right? So let's look at the first one. X squared plus 3. Can I rewrite this like that? Is it the same thing? It's the same thing, right? So what's the value of c in the first case?
Root 3.
Root 3, exactly. So what about this one? This is actually, what's the value of c in the last case? Root 12. So as long as I see x squared plus something, doesn't matter what the something is, as long as it's a plus something, it cannot be factorized further. Okay? Darius. 22. There are a few things that we have to learn from this example. 7x squared plus x plus 15 over x cubed plus 3x. Okay, express this in partial fraction. First thing to do, always check if it's what? Check if it is a what fraction? Proper. If it is proper, we can proceed. So is this a proper fraction? Yes, very good. Next step, I need to factorize the denominator so that I know what my partial fractions are going to look like. Right now, it's just one whole chunk, x cubed plus 3x. Can you factorize that? Can you factorize x cubed plus 3x? No? Cannot? Can. A Sec 1 student can factorize it. So don't think too much. How do you factorize it? Take out x. Okay, so x squared plus 3. Agree? That is in my denominator. So 7x squared plus x plus 15. Okay, now I am ready to separate them. Oh wait, am I ready to separate them? What about this x squared plus 3? Can I factorize it? Can I factorize it? X squared plus 3? Cannot. What if it becomes x squared minus 9? Can I factorize? That becomes what you know it to be lah. Okay, so let us factorize. This becomes over x plus over. We always put a plus, okay? Always put a plus. Then what is in the other denominator? X squared plus 3. Okay, what goes in the numerator over here? A? Is that all? A. Okay, what about the other one? B. Can I teach you something else? Huh? So far we've been dealing with numerators, A's, B's, C's only. That is when all the denominators have degree of 1. Okay, let me go up. Over here. See, the degree over here is 1, degree over here is 1. That is why over here we've got degree 0. Okay? Then we go down over here. Degree 1, degree 1, degree 0, degree 0. Over here, degree 1, degree 0. It will always be smaller. Over here, degree 1 or 2? Degree 2. Then how come over here degree 0? So you work backwards, right? You go and choose one of the examples that is given in your textbook. You work backwards. You should be able to convince yourself why this should be degree 0. Okay, I'll leave that to you to find out. But our conclusion is that whatever the degree is in a denominator, degree in the numerator will be less. In this case, if it is degree 1, we will have degree 0, which means no x lah. Okay, Darius, are you ready to sit down? Okay, sit down. Now, over here, what is the degree? 2. What do you think the degree in the numerator should be? 1. Okay, give me an expression, a polynomial of degree 1. Bx plus c. Don't forget, bx plus c is also a polynomial with degree 1. Okay, just that sometimes c could be equals to 0, maybe, I do not know. Okay, so this is the general form that we're going to have. Once we have this, do you know how to proceed? Do you know how to proceed from here? I've got a original fraction equals to partial fractions. Can proceed by yourself? Yes, what should we do first? Not yet, haven't let yet. Multiply throughout, yes? So what do I have on the left hand side? 7 x squared plus x plus 15 equals to a. Okay. Do I need brackets for bx plus c? Or should I just write it like that? Okay, so this is a common problem that many students have. Somehow they develop this habit since lower sec. They refuse to draw in the brackets for bx plus c. But they remember that actually I'm multiplying the whole thing with x. So when they continue with their steps, right, they will actually write this bx squared plus cx. Okay, this is what they will write. While this step is correct, this step is wrong because you didn't put the brackets. And since you have the first step over here wrong, you cannot tell me that they are equal. So I will consider this wrong as well. Do you understand? To me, these are two mistakes made. First, you forgot to put in the brackets. Secondly, you don't even know how to expand. By right, it should have been bx plus cx. Okay, so to me, there are two mistakes. It is not that I will close one eye and give you full marks. So, you must write down, you must draw in the brackets. Over here. Basic maths. Please don't get it wrong. Okay, from here on, what's a good way to solve for a and b? What would you like x to be? So we again let fx be equals to 7x squared plus x plus 15. So what would you like x to be? 0. Okay, sounds good. So we have on the left hand side 15. At the same time, it is also equals to a times 3. Agree? So what's a? Right? Similarly, you can substitute in values to find b and c. Okay? Okay, your turn to try. In this case, you end up using simultaneous equation, but it's a simple simultaneous equation. So now, practice. Now, 22a, question 1. How long do you think you need for this? How long do you think you need for this? 5 minutes. Okay, very good. 8:25. Is it a proper fraction? Is this a proper fraction? Yes, it is. So this is a proper fraction. Next step, I want to rewrite it into partial fractions. A over x plus 1 plus, since x squared plus 2 cannot be factorized, I am going to have x squared plus 5 in the denominator. Numerator will be bx plus c. Multiply throughout, I have 5x squared plus 12x plus 9 is a times 2x squared plus 5 plus bx plus c with the brackets x plus 1. Let fx be equals to 5x squared plus 12x plus 9. I'm going to try and get rid of this entire expression over here by letting x equals to -1. When x equals to -1, I have a x squared, which is 1, plus 5, which is 6. That's your mistake. Plus 0. So I don't need to write anything. And over here, on the left-hand side, when I substitute x equals to -1, I will have 5. -1 squared will be 1 plus 12 times -1 plus 9. This gives me 6a equals to 14 minus 12, 2. So A equals to 1/3. First unknown solved. Next one, I want to let, I can let x be anything I like. Okay. Now I'm going to sub, let's say 0. Equals to, on the right hand side, I've got A. Oh, I already know the value of A. Let's just use it already. That is 1/3 times 5 plus C times 1. Okay. And on the left hand side, it is supposed to give me 9. You see, some of the steps are just skip them if you can do them mentally. So this tells me that C equals to 9 minus 5 over 3. How much is that? 22 over 3. Okay, so I've got C now. One last unknown to find. What do you think is easy for us to substitute in? 2. Can I try 1 instead? I think 1 is slightly easier. So on the right hand side, I substitute 1. I've got 1/3. 1 square plus 5, that is 6. Plus B times 1, which is B. Plus C, which is 22 over 3. Multiplied by 2. On the left hand side, I have 5 plus 12 plus 9. In summary, I've got 2 plus 2b plus 44 over 3 equals to 26. Am I right? Okay, so now I just want the b. So 2b equals to 26 minus 2, which is 24, minus 44 over 3. What is 24 minus 44 over 3? Minus 44 over 3. So this is 28 divided over 3. Therefore, b must be equals to 14 over 3. Okay, here I have my 3 values, a, b, and c. So c, got b, and I've got a. Substitute all of them back into my original partial fraction. You shouldn't be dividing your page, but I'll just show you over here like this. Easier for you to see. Therefore, 5x squared plus 12x plus 9 over x plus 1, x squared plus 5 must be equals to a, which is 1/3, over x plus 1 plus b, 14 over 3x plus c, which is 22 over 3 over x squared plus 5. Now, we are very uncomfortable with a fraction in a fraction. So what do? Take note that this portion over here, some basics are for fractions. This simply means 1/3 divided by x plus 1. Am I right? It simply means that I can rewrite it to become 1/3 times 1 over x plus 1, which is the same as 1 over 3 x plus 1. We apply this approach and we will always be able to see the pattern. Very simple. This denominator, simply bring it down. Okay, and it will work. This is the shortcut. But on the right hand side, this is the approach. So applying that, we will have now equals to 1 over 3 x plus 1 plus, on the other side, factorize out the 1/3 first if you can't see it straight away. So we got 14x plus 22 divided by x squared plus 5. Same thing, this 1/3, we're going to move the 3 down for the same reason that I mentioned over here on the right. Remove the brackets, done. Is this the correct answer? Yes. Case 4 is really, really easy. Do you know how to do long division?
Yeah.
Yes. Do you know how to do partial fractions already?
Yeah.
Yes, then you know case 4 already. Example. Let us look at page 38. Okay, we are given 4x cubed plus 8x squared minus 50x minus 132 over 2x squared plus x minus 28. Express this in partial fractions. Some things that must be going through your mind. Come, what are they? What should be going through your mind? Okay, is it proper? Okay, it is not. So I need to do long division. Do you know how to do long division for this? Yes, okay. Then do your long division. We will end up with... Okay, let me just put this on the side. Do your long division, blah, blah, blah. You know what to fill in over here? We end up with 2x plus 3 as the quotient. And then for our remainder, we have 3x minus 48. Okay, now that we have our long division, we need to be able to rewrite the original fraction. Given the quotient, given your divisor, which is this quadratic over here, and given our remainder, let us put them down. Let us rewrite this fraction, okay? So this equals to the quotient, 2x plus 3, plus remainder, 3x minus 48 divided by our divisor, 2x squared plus x minus 28. At this point in time, anybody lost? Is there anybody who is lost for this step? Crucial step. But it is just long division. Ready? All okay? Alright, then now, this is not a fraction. Ignore it. This over here is a fraction. And we are going to rewrite this as a partial fraction. Okay? Now, the denominator, 2x squared plus x minus 28. Can you create a partial fraction out of this?
Factorize.
Yeah, you need to factorize it. Okay? So let's skip a few more steps. You all know how to factorize. We are going to end up with 2x plus 3. Nothing changes. Numerator doesn't change. 3x minus 48. Over, when I factorize it, we will get x plus 4. 2x minus 7. Okay? So, there are two steps already so far. Are these two steps anything different from what you have learned? No, nothing different. All the same. Now, this is our fraction to be separated into partial fractions. Do you think you can handle this? Yeah, you should be able to handle this. Huh? So, we can continue writing. Let 3x minus 48 over x plus 4, 2x minus 7. Now take a look, I've isolated the fraction. I want to work on the fraction separately. So this must be equal to, okay, come, guys. X plus 4, and the other one, what is the denominator? 2x minus 7. Notice that I didn't check whether it is proper or improper. I didn't check whether it's proper or improper, right? Should you check? You should always check, but after you do long division, I guarantee you it will be proper already. Because you stop your long division when you can't divide anymore, and therefore it must be a proper fraction already. But it's always good to check, okay? So in the numerator, what do we have over here? A. And the other one? B. Can solve by yourself? So next, let fx be equals to 3x minus 48. Okay? And this will be equals to A multiplied by 2x minus 7 plus B x plus 4. Now, this is relatively easy, isn't it? That's all for case number 4. And that concludes our partial fractions topic. Shall we try one question? Practice now 22B. Let's see whether you can do it